Hi guys. During my time at Abertay, I did some research regarding networking, and well, this is actually a time ago already, but I finally decided to make a video about it. And my project was basically to create a networked Boid simulation where you have the servers that are connected peer-to-peer to each other, and you can just connect to it and see the simulation happen on the servers, but you will just have a display of it, and your computer doesn't really have to do any like performance related stuff, so you can just run it and just watch. You can just watch and add the boids to the system. So I made some scripts to actually start it, because it's a bit of a pain to start it. Now I'm starting two servers up. They're both run locally on my own computer, but with different ports, so you can just connect clients to it. We've got our first server on the left here, and our second server in the middle. And to connect to the first server, I'll just run my other connect script, which just launches the client, but with a connect command argument. As you can see, it just let's see which one to connect it to. It connected to one of the two. I'm not sure which one because I didn't log it out. If you left click on it, you can just see the boids up here on the screen in your client here, but they also appear on both servers, and that's because both servers actually transmit data to each other to keep themselves up to date. What will happen is the server has a maximum number of boids to simulate, which means it won't simulate more than, like, I think 100 right now. And if it goes over that amount, it will try to offload them to a different server. It's just a theoretical thing to do. In reality, these things could handle way more boids, but yeah, it's just learning purposes. So if you add lots of boids on the middle server has like the transforms active, which means those boids are actually simulated on that server. If you look very closely, you can also see on the left server that it's a bit choppy, and that's because there isn't any interpolation between the data packets, which does happen on the client, which makes it easier to actually optimize away sending like lots of data packets per frame, because you have loads of boids. Let's connect to the second server as well. So we have two clients active on two servers. Every client that connects to a server will actually, the boids that you spawn in that client will actually get simulated on the server that you connected to first as a priority, and then will actually offload to a different server. And each client can actually move their boids around. It's just to show off how you actually can influence the world. And a second optimization I've done was, instead of actually sending each boid their position every frame, I keep track of how much the boid diverges of the last time it was actually updated on the network. So if it wasn't updated or was just not noticeable, if it's just going in a straight line, I don't even bother sending packets. I just keep interpolating and actually extrapolating until it's too far from the actual result of the server, or like if the mouse and stuff has moved too much, we'll have to re-update everything. The boids actually loop around the screen. Currently it's a bit weird because the interpolation actually makes them look like they float to the bottom of the screen and then return there. I didn't really put any maximums in there to actually teleport stuff around. So yeah, that's pretty much message actually from this application. It's built using SFML, and it's also using WinSockets. Well, SML internally uses WinSockets, but I've also done research on actually how to make your own wrappers and use WinSocket and bind your own ports and stuff like that. I hope you enjoyed watching this video, and feel free to check out my portfolio page.